Yesterday in class, we talked about two different types of sequences. And we said that a sequence is simply a group of numbers that has a pattern that is consistent between each of the numbers. Now, the two that we talked about yesterday were an arithmetic sequence and a geometric sequence. We said that arithmetic sequences have a pattern where you add the same number every time, and that number that we add every time is called a common difference, while a geometric sequence is where we multiply to get to the next term, and every time that we multiply, it's going to be by the same number called a common ratio. So today, we're going to focus on two different formulas for arithmetic sequences. So an arithmetic sequence is a sequence of numbers that have a common difference, and remember we called that variable b. And yesterday we talked about the explicit formula for an arithmetic sequence, which is where a sub n is going to equal a1 plus d times n minus 1. N is going to represent the term number. So again, what place does it come in? The term number. And the term number simply is the place. First, second, third, etc. D will represent the common difference. So what did we add? And even if we're subtracting, remember we can talk about that in terms of addition. If I have a sequence 30, 27, 24, you might say that I'm subtracting 3, or I can talk about that in terms of adding a negative 3. A1 is going to represent the value of the first term, where a sub n represents the value of the nth term. So whatever place I'm looking for here. Okay, so this is what we need to remember. We also talked about yesterday, for this explicit formula for arithmetic sequences, we could have an open or a closed version. We said that open version is exactly what we have here. And the reason we know that it's open is because it has the n minus 1 in it, and it is simply not simplified. If I have a closed version, we will have just an n in the problem, and it is simplified. And as we do some examples, you'll see differences between these two things. All right, so now what we want to do is build some explicit formulas. So it says find the common difference for each arithmetic sequence, then write the formula, and use that formula to find the specific terms. So I have to look at 5, 14, 23, 32, 41. And I have to ask myself, what did I do to 5 to get to 14? What did I do to 14 to get to 23, 23 to 32, and 32 to 41? Now I know because it says a common difference here that I have to add. So what did I add to 5 to get to 14? And I can tell that is a positive 9. So that's going to be my common difference. So all I have to do is now follow my formula that we just wrote out, a sub 1 plus the common difference times n minus 1, in order to find this term. If it's asking me for the nth term, then I'm going to leave a sub n in the problem. My first term in my sequence is 5. We just found the common difference to be 9. Because I left n in the problem, I'm going to leave n, and then it's always minus 1 because I'm already using my first term. Now at this point, we need to remember that what we just created is the open explicit formula. If I wanted to close this, what I would need to do would be to distribute the 9, just like when we were multiplying polynomials. So I'd have 5 plus 9n minus 9. Then I would need to combine my like terms. So I would get 9n minus 4. Now this is going to be the closed explicit. And you'll see in just a moment that it doesn't really matter which one I choose to plug things into. It's going to give me the same answer. Okay, so I can see the problem is asking me to find the 7th term. Now I might be able to list out 7 terms here to continue and add 2 more to be able to find this, but I want to practice using my formulas. And I'm going to do both for this first example. If I want to use the open explicit formula, all I'm going to do is say 5 plus 9 times 7 minus 1. And I want to type that into my calculator the exact same way I see it. So again, it'll be 5 plus 9 times 7 minus 1. Make sure that that 7 minus 1 is going to be in parentheses, because if it's not, the calculator is going to give you a wrong answer. Also, if you can do 7 minus 1 in your head, then that's fine. You can go ahead and just type in a 6. But when I do this, I will get 59. Now that's by using the open formula. If I want to come and use the close, I'm going to say 9 times 7 minus 4 and put that into the calculator. And I should get the exact same answer, that the 7th term will be 59. So it's completely up to you. This problem does not specify whether we need to use the open or the closed formula. So if I were you, I'd practice doing some of both. Now, if I'm going to find the 11th term, we'll type it into the open formula first. So it would be 5 plus 9, but instead of a 7, now we're going to use an 11. Take a second, put that into our calculator. Where we get our 11th term to be 95. If I want to use the closed formula here, again, I would just say 9 times 11 minus 4. So 99 minus 4 is 95. Again, I don't care which version you use because it doesn't specify. You just need to be in good practice to use both. Now, finally, for the 24th term, when I plug it in, it'll be 5 plus 9 times 24 minus 1. Remember, the only thing that's changing on every single one of these is the term number that I'm looking for, and I'm using that to replace n every single time. So when I do this, I get 212. So the 24th term will be 212. If I wanted to use the closed explicit formula, then I would say 9 times 24 minus 4. And again, that'll give me 212. As I look at this next one, negative 84, negative 69, negative 54, negative 39, negative 24. You might be saying that it's rather difficult to find the common difference here. Well, what you can always do is take your second term and subtract the first term from it. So anytime you need to check this, you take the second one and you subtract the first one. So in my calculator, what I'll do is negative 69 minus negative 84. Now remember, we do minus and negative 84 because this is a common difference, and we know that we add to find the next term, so we want to undo that. And hopefully you can see here that our common difference is going to be 15. If you can't tell by the first two terms, and maybe there's an easier term for you to look at, you can totally check any terms in there. So as I get ready to set up my formula, again, we'll open it and close it at the same time. My first term is negative 84. My common difference was positive 15. And if I'm leaving it open, it's always n minus 1. So again, this would be my open version of the explicit formula. If I wanted to close that, I would need to distribute the 15. So I'd have negative 84 plus 15n, and then minus 15. And then I would simplify my like terms here. So I would have negative 99 plus 15n. Okay, so this would be the closed version. Again, it doesn't specify which one we need, so it's completely up to you as to which one you want to pick. Now, if I want to find the 9th term, I can use either one of these two. I'm just going to use the open formula for the first one and plug in, instead of an n, I'm going to use a 9. So negative 84 plus 15 times 9 minus 1. And you just want to type that into your calculator. Again, making sure you use your parentheses. If you don't, it's going to give you a wrong answer. So I get that the 9th term here will be positive 36. Now let's say that I wanted to use the closed formula for number 15, or for a of 15, which means the 15th term. So I would simply do negative 99 plus 15, and then I'm looking for the 15th term, so I'd plug that in. And I got the 15th term to be positive 126. If I wanted to find the 26th term, I'll go back to the open formula. We get negative 84 plus 15 times 26 minus 1. Again, remember, please, that the open formula uses my first term and my closed formula does not. So you might be thinking, well, why is there a negative 99 when we use 15 here? It's because we were using the closed formula. And you're only going to see your first term when you're in the open form. So as we type this in, negative 84 plus 15 times 26 minus 1, we get the 26th term to be 291. So as we're looking again at number 3, we want to find the common difference again before we can start. If you're having a hard time, you can take A2 and you can subtract A1. So negative 15 minus negative 11. And when you do that, you get negative 4. Hopefully you can tell that I am adding negative 4 every time here. So as I set it up, I want to find the open forms. My first term is negative 11. My common difference in this time is going to be negative 4. Because I want the open formula, I'm leaving the n in the problem. Now remember, to close this, I'm still going to distribute the negative 4. So I'll have negative 11 minus 4n, and then negative 4 times negative 1 gives me positive 4. So to close it, I'll need to combine like terms, where I'll get negative 4n minus 7 here. That's my closed form. And to go back and continue practicing what we have, the 6th term, I'll continue on the path that we were using. So go to the closed form, negative 4 times 6 minus 7. So if I type that into my calculator, I get the 6th term will be negative 31. If I'm finding the 16th term, this time I'll go back to my open formula, just to give you more practice with each. Negative 11 minus 4 times 16 minus 1. Let me type this in. And I'll get that the 16th term is negative 71. And the last thing they're going to ask me to find is a sub 25. So I go back following my pattern. I'm going to use the closed formula. So negative 4 times 25 minus 7. And I'll find that the 25th term in this case is negative 107. As we move on through the notes, we see example number 4. And these are asking me to write an explicit formula of an arithmetic sequence based on information given. It's not telling me specifically whether it has to be open or closed, so this is completely up to you. Now, I like to start because they tell me what the first term is. I start with the open form because I know if my first term is 2, then I can start, and again, I'll give you this formula, which is a sub n I'll give you the formula, which is a sub n equals a1 plus the common difference times n minus 1. So if they tell me that the first term is 2, then I know it's 2 plus the common difference is positive 3, and then n minus 1. So this will be my open form. If I chose to close it, I would simply distribute, which means I'd have 2 plus 3n minus 3. And then I would combine like terms. So my closed form will be 3n minus 1. Completely up to you which one of these two things that you choose. Now I can go through and I have options on how I want to fill in my chart. They told me the first term is 2, so I come to the first term. I can go ahead and put a 2 here. I can either plug into my open explicit formula, I could plug into my closed explicit formula, or I can read here that the common difference between every term is 3 and just do this. So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14, and 14 plus 3 is 17. And then I would just need to transfer that to these lines here for my first 6 terms. 2, 5, 8, 11, 14, and 17. There's lots of options here, and as long as you can find those first 6 terms, it doesn't really matter to me how you choose to do it. As we look at number 5, we want to go back and start with our open explicit formula. It tells me that the first term is 5, and the common difference between the terms is negative 4. Well, I want to multiply that by n minus 1. And again, that's the open formula. If I wanted to, I could come in and fill in my chart next. My first term was 5. 5 minus 4 is 1. 1 minus 4 is negative 3. Negative 3 minus 4 is negative 7. Negative 7 minus 4 is negative 11. And negative 11 minus 4 is negative 15. So I hope that you're seeing here, it doesn't really matter the order that you do these things in as long as you are getting the correct answers. And if you wanted to close this, you would be doing some distributing. So it'd be 5 minus 4n, and then negative 4 times negative 1 gives me positive 4. Combine these like terms, so I get 9 minus 4n, and that would be the closed version. Completely up to you on whether you want to use the open or the closed. Now let's move through. This is going to give you some specific notes about the closed formula for the explicit arithmetic. So because an arithmetic sequence, because the arithmetic sequence is a linear function, because we're adding every time, we say that this can be written in slope-intercept form. And remember, slope-intercept form is y equals mx plus b. This is called the closed or simplified form. Here's some easy steps. Write the explicit formula to begin with in open form using a sub n equals a1 plus the common difference times n minus 1. You want to then distribute. We've been doing this. The common difference throughout the parentheses. Then we want to combine like terms, our constants. And then write a sub n in its linear form in terms of n. So instead of y equals mx plus b, we will use y equals, in this case, dn plus b, where d is my common difference and n is the term value. Truly what we're doing is just replacing the x with an n. So they want us to just practice closing these. We've been doing this, hopefully you remember. Negative 14 plus 4n minus 4, combine like terms. So I get 4n minus 18. For number 7, we still want to distribute. 31 plus 100n minus 100. So I get 100n, combining these like terms, minus 69. For number 8, we want to distribute again, so the negative 100 will get multiplied by the n, and the negative 100 by the negative 1. So negative 26 minus 100n plus 100. So I get negative 100n plus 74. Finally, for number 9, we want to distribute our negative 2. So we get 38 minus 2n, and negative 2 times negative 1 is positive 2. So I get negative 2n plus 40. As I move through, now they want me to practice even more. We've been doing this. Given our common difference in the first term, create a closed explicit form. So remember, you want to start in the open explicit. My first term is negative 18. I add my common difference of 100 times n minus 1. Then I just distribute and simplify. So negative 18 plus 100n minus 100. That'll give me 100n minus 118. For number 11, first term is 38. We add that to the common difference of 5 times n minus 1. Remember, you have to have it open before you can close it. So I distribute the 5. We get 38 plus 5n minus 5. Combine like terms, 33 plus 5n. Now for the next examples, they've given me the first 4 terms, and they want me to set up the closed explicit. So remember, before we can close it, we have to open it. Pretty simple here because my first term is going to be given. So my first term in each of these problems is given to me. Then I just need to find my common difference. So I have to ask myself, what did I do to 13 to get to 15, and 15 to get to 17, and 17 to 19? Hopefully you can see that we added 2 here. So if I'm setting up my equation, I have 13 plus 2 times n minus 1. To close it, we want to distribute. So 13 plus 2n minus 2, which gives me 2n plus 11. For number 13, my first term is 26, but I need to find out what did I do to 26 to get to 17, what did I do to 17 to get to 8, and what did I do to 8 to get to negative 1. And if this doesn't jump out at you, remember you can take the second term and subtract the first. So you do 17 minus 26. And you'll find here that our common difference is adding negative 9. So if my common difference is negative 9, I multiply that by n minus 1. I need to close the formula by simplifying. So 26 minus 9n plus 9. And I get the closed version to be negative 9n plus 35. Now, as we talked about, there's a second type of formula for an arithmetic sequence that we can find. We said that an explicit formula gives us a specific number. So if I want to find the 102nd term, then I can totally do that. Well, the recursive formula is simply going to be useful when we're finding the previous term in a sequence, okay, or the next term. So we have to use the previous term in order to find the next one. So this would be the recursive form. And it's going to be useful when we're finding the next term in a sequence. So if I have one specific term and I want to find the one that comes right after it, that's what I'm going to use, the recursive formula. And honestly, I believe the recursive formula is a little bit more simple because there's parts of this that will never change. So if you see this a sub n equals a sub n minus 1, and then I have plus d, and then I always have a sub 1 equals. So there's 2 parts to this. You'll always have 2 different pieces. A sub n, as always, is going to be the term value. That part will not change. Okay, so whatever value I'm looking for. Well, a sub n minus 1 is simply going to be the previous term. D is still going to represent the common difference, so the number that I add by every time. Even if I'm subtracting, remember I can talk about that in terms of addition, so I'm adding a negative. And a sub 1 is still going to represent the first term. So the first thing we have to do in a formula like this is determine that the sequence is actually arithmetic. So I added, you have to make sure that you know that I added to get to the next term. Step 2, make sure that you identify what the common difference is. So what did you add every single time? So after that, you just want to create the recursive formula using the previous term. And in that previous term, we want to add the common difference to it. Make sure you talk about that. And then you want to indicate what the first term of the sequence is. And hopefully as you see us do these examples, you're going to see that this is very simple. Okay. First thing you always want to do, parts that will never change in recursive formulas. I see the word recursive. I need to determine which type of sequence it is. So 7, 10, 13, 16, I added 3 to get to each term. I always set it up, a sub n equals a sub n minus 1. That part will never change. We said it's a common difference, and that common difference was a positive 3. So what I did to this problem is I added 3. And then for the last part, I just have to identify what the first term is. So in this case, my first term is positive 7. Some people like to go through and list their first term before they do anything else. That is completely fine. It's however you choose to do it. Just don't forget that each one of these formulas needs 2 parts to it. For number 15, we have 386, 365, 344, 323. So as I'm looking at this, I can determine that I subtracted 21 every single time. So part that never changes, a sub n equals a sub n minus 1. If you had a hard time determining that we subtracted 21, then you would just put this in your calculator, 365 minus 386. And that's where you would get the minus 21. And then I just go through and identify the first term, which was 386. Okay. As we continue on for number 16, part that never changes, a sub n equals a sub n minus 1. My first term here is negative 3. Now don't forget to determine what the common difference is. If you're having a hard time looking at this, remember to type in negative 8 minus negative 3. My numbers are getting more negative, so I am subtracting 5. You have to have both parts in every single one of these. Okay, so I have 3.2, 3.5, 3.8, 4.1. Hopefully you can tell that this common difference is adding 0.3. So the part that never changes, a sub n equals a sub n minus 1. And then we said that we added 0.3. And my first term in this case was 3.2. The next part is simply asking us to list the first 5 terms. This should be pretty simple. My first term is given to me, so 31, and then I just have to do what the problem tells me to do. And in this case, it's saying subtract 200, so that should give me negative 169, and I would subtract 200 from that to get negative 369, subtract 200 from that to get negative 569, and subtract 200 from that to get negative 769. As I look at this next one, my first term is negative 19. That goes down. And I'm going to add 5. So negative 14, negative 9, negative 4, positive 1. All right. Another way to build our recursive formulas here is they want us to use the values that are given and just create the formula. Well, this one's easy. A sub 1 equals 26. Go ahead and fill that in. Then all you have left is the part that never changes. A sub n equals a sub n minus 1. And it said my common difference is positive 100. For 21, my first term is 2. Part that never changes. A sub n equals a sub n minus 1. Common difference here is positive 10. Now, for the last little bit, it's asking us to create and build the recursive formula out of these things. Now, for the first one, we need to identify that this is the open explicit formula, which means my a sub 1 is given and my common difference is given, which is really nice. Part that never changes, a sub n minus a sub n minus 1, and then it's positive 4, where my first term was negative 3. I have to be careful on number 22, though. The reason I have to be careful on number 22 is because this is in the closed explicit form, which means I do have my common difference here, negative 9, but I don't have my first term. So in order to find the first term, what I'm going to have to do is plug in a 1 for n. So 43 minus 9 times 1, because I don't have a first term here. And when I do that, I find that my first term is really 34. Once I have that, then I can go in and build my actual my recursive formula from the explicit. So the part that never changes, a sub n equals a sub n minus 1. My common difference is minus 9. And my first term is 34.